Our sixth objective of Practice Test B on acids and bases has us using our pH formula and the molarity formula, so some good things to remember as we proceed. I know that pH can be found by taking the negative log of the concentration of the acid ion, H+. We know that pOH can be found by hitting negative log of the base ion, hydroxide. And we know that their sum, the pH with the pOH, must give us 14, the top of our scale. Keep in mind from the earlier objectives that molarity is defined as moles of solute per liter of solution, and that when we place these brackets around the ions of acid and base, hydrogen and hydroxide, those brackets indeed mean the molarity unit. Let's take a peek at our first example of Objective 6. Calculate the pH of a solution made by dissolving 0.08 grams of hydrochloric acid in a total volume of 3,500 mils. Before we can calculate a pH, we have some molarity work to do. I notice that it's giving me an acid, and an acid releases hydrogen ions. I can calculate directly the acid concentration and go into the pH formula. So if I take my 0.078 grams of hydrochloric acid and using a mole map relationship, the molar mass of HCl, adding 1 H to a chlorine gives us a molar mass of 36.5 grams. So grams divided by formula weight, and I'll hit for us. 0.078 divided by 36.5 equals, and that leaves me with 0.00214 moles of HCl. We'll need to place that over the liters of solution. 3,500 millis, sliding that over to create the liter unit, 3.5. Let's hit for the big M, the molar solution. So 0.00214 divided by 3.5 equals. The moles per liter is a small number, 6.114 times 10 to the negative fourth molar units. And that represents the concentration of our acid, and it represents the concentration of our hydrogen ion. So to turn that into a pH, we hit the negative log of our answer, 6.114 times 10 to the negative fourth molar units. So on our calculator, to share that journey, I started by taking 0.078 divided by the molar mass to find moles, 0.00214. From there, I divided by the volume, 3.5 liters, and now I'm staring at molarity on the screen, 6.114 times 10 to the negative fourth. I'll negative log my answer and find the pH of our solution, and I'm finding it to be 3.21 pH units. Our pH falls in the acid range, which it should. It's an acid, hydrochloric. Reading for the second one. Let's calculate the pH of a solution made by dissolving 2.5 grams of rubidium hydroxide in a total volume of 1,250 milliliters. Noticing that we're given a base, rubidium hydroxide, RbOH. So therefore, when we find the concentration of this solution, remember it will be giving us a pOH. Let's begin. The 2.5 grams of rubidium hydroxide. We need to do a little mole map work to convert it into a mole. Let me add for us rubidium hydroxide. Rubidium, 85.5 we'll say. Rubidium has a weight, 85.5, plus 17 for an O and an H. That gives me 102.5 grams for every 1 mole of the rubidium hydroxide. We'll take our 2.5, we'll divide it by 102.5, the molar mass, and now we have solved for 0.0244 moles of RbOH. We need that in a molarity, moles per liter. 1.25 liters of solution. 2.5 grams divided by molar mass found moles. Moles per liter finds us, divide by 1.25, finds us the 0.0195 molar units, but it's a base. It's a hydroxide concentration. Remember, if it's an OH, we find something called a POH. The negative log of our answer gives us POH. So, when I hit negative log of our answer, I find 1.71, but that's its POH. Don't be done. We have to flip it to a pH. And to do that, we simply go 14 minus our POH, and we find the pH, 12.29 pH units. Which makes sense. On the pH scale, bases have pH numbers above 7. In our first example, we had an acid. We can calculate pH directly from an acid ion concentration. But in number 2, we had a base. When we find the concentration of a base, we find something for a POH. The 14 minus POH flips that into a pH reading for us. Let's try our last one, number 3. Calculate the pH of a solution made by dissolving 10 grams of hydroiodic acid in a total volume of 70 liters. 10 grams of hydroiodic acid is HI. We'll use our molar mass relationship to find the number of moles. So an H added to an I gives us 127 grams of hydroiodic acid. 10 divided by 127 pulls out the number of moles, 0.0787 moles of HI. We'll divide that by our volume of 70 liters, moles per liter. So divide by 70, and it gives me 0.00112,485, how many decimals you'd like. So 0.00112 will be how much I write for the molar concentration. And this is an acid, so it's giving me a hydrogen ion directly. So in this case, we can hit negative log of our answer and find the pH directly. So we'll go back and hit negative log of the answer and turn our molar concentration of hydrogen into a pH 2.95 following the 2 decimal place rule. 2.95 pH units. The first example gave us hydrogen ion for an acid. The third example gave us hydrogen ion due to the acid. It's the second example that we had to do 14 minus because it was a base. When we found the molarity of our base, it gives us POH. Keeping that in mind will earn us our next A+.